Hello, guys. Welcome back. We have completed the topic of acids along with its reactions, different types, and ionization equations. Right now, we are going to discuss about bases. So, what are bases? First of all, bases is another category of the compound which are entirely, you may say, a different class of compounds as compared to acids. Let's read and let's go into the concept of bases. Okay, guys. So, bases are basically metal oxides, metal hydroxide, metal carbonate, and ammonia are called bases collectively. Okay, so some of the bases are water soluble, some are water soluble, whereas the other are water insoluble. Now the point is this, that those which are soluble are called alkalis, okay, are called alkalis, whereas those which are insoluble don't have any specific name, they are just called as bases. Okay, let's discuss this thing in detail. So we can say right now, instead of moving to the next page, I would like to draw it here so that you people may have a clear idea. So for example, this is a big circle, and in this a small circle is there as well. Okay, so we can say this thing, that this big circle is called bases and this small circle is called alkali. Okay. Now the point is this, that alkalis are those bases which are water soluble. Okay, so they have some specific name. That's why they are called as alkalis. They have some specific properties of being soluble in water and act in different direction. So we can say that alkalis are those bases which are water soluble. All bases are not water soluble. Which bases are water soluble and which are insoluble, that we are going to discuss. So there is a dual property for metal carbonate as well. And what is that dual property? Let me tell that as well to you, that when metal carbonates are reacting with an acid, they are behaving like a base, and when metal carbonates are reacting with a salt, they are behaving like a salt. Okay, so metal carbonate has a dual type of a property. That dual nature I have discussed with you, that it can act as a base and it can act as a salt. Okay, so when it is acting as a salt and when it is behaving like a base, that has been discussed. I have just told it to you. Okay, let's change the page and move on to the next properties. Okay, so for example, sodium oxide is a base, sodium hydroxide is a base, sodium carbonate is a base, ammonia is a base, and ammonium hydroxide is a base. Okay, I should say that ammonia and its oxide along with its hydroxide and its carbonate are bases as well. Okay, so we can say that bases are metal oxide, metal hydroxide, metal carbonate, ammonia, ammonium oxide, ammonium hydroxide, and ammonium carbonate. So this is a big category of bases. Okay, let's change the page, and this is ammonium hydroxide, ammonium oxide, ammonium carbonate. All these are considered as bases. Okay, so for example, these are the few examples of the bases which we have just discussed. Okay, let's discuss few more things, that which bases are soluble and which bases are insoluble. So let's have a clear discussion on this. Group number 1, strontium, barium, ammonium oxides, and hydroxides are soluble. So these are called as alkalis, as well as alkalis and bases. These will be called as alkalis as well as bases. These are those bases which can be considered as an alkali. So right now, for example, which carbonates are soluble? All carbonates are insoluble except group 1 and ammonium, except group 1 and ammonium. Okay, so these are the insoluble ones, the carbonates, and these are the soluble ones, carbonates. So for example, if we are considering copper carbonate, it will be considered as an as a base only. It cannot be considered as an alkali because copper carbonate is not in the category of the soluble ones. Okay, let's have a discussion further on this. There is a reaction which is called neutralization reaction and other reactions of bases as well. but I would like to bring your attention on this. For example, we are saying that zinc hydroxide, okay? Zinc hydroxide is a base. How we know? Because it is a metal hydroxide, it is a base. So can we say it is on the category, it is in the category of those which are alkali? No, it will be considered as a base only, okay? Base only, as is insoluble, okay? So we have to have a very clear idea that which bases are soluble and which bases are insoluble. So soluble bases are the carbonates of group number 1, carbonates of ammonia, and metal oxide and metal hydroxides of group number 1, and strontium, barium, and ammonium. So these are the only bases which are water soluble, called as alkalis as well. Rest of all are only bases. They are not called as alkalis because they are insoluble, okay? There are three types of the reactions of bases in your syllabus. Number 1, I am writing here reaction types. Reaction types, and bache, what are those? For example, number 1 is neutralization. Neutralization, and number 2 is metal metal displacement reaction. Metal dash metal displacement reaction, okay? And number 3 is reaction of base and ammonium salts, okay? Reaction of base and ammonium salts. These are the three reactions which we are going to study in detail regarding bases. Okay, let's change the page, and we are right now on neutralization. This is one of the very famous and an important category of the reaction, which is called neutralization. In neutralization, basically an acid is combining with a base, and both of them are neutralizing each other's property. After the reaction, no acid and no base is left. Basically, they both react with each other in a specific ratio, definitely. So might be if acid is in excess after the reaction, acid will be left along with the product. If base is in excess after the reaction, base will be left after, with the products, along with the products, okay? But if they are according to the requirement of the balanced chemical equation, then they will not be left at the end. Rather, they will complete each other's reaction, and finally nothing will be left at the end of the reaction. So this is how neutralization is working. Let's write down the reactions of neutralization in different scenarios. Okay, so for example, we can say that HNO3 is reacting with a base called NaOH, and as a result, what will be formed? NaNO3 along with water as well. Okay, so this is how this reaction of neutralization is happening. So here we are saying that in neutralization, basically salt along with water is forming. So we can say that it is one of the example of neutralization. Okay, let's have some other examples of neutralization. We can say that in case of an acid, let's take H2SO4 along with another base K2O. What will be the product? K2SO4, and this is H2O along with this. Okay, might be some of you may be thinking an idea like this type of the reactions we are done in the topic of acids. Yes, we are done such type of a topics in acids. Over there, I have not told you that this is neutralization. So basically, as I have not taught you the concept of basis till that stage, that's why I have not taken the term of neutralization. Now you know what are acids, what are bases, and their reaction is called as neutralization. Okay. So we can take another acid. This is CH3COOH, and this is now reacting with calcium oxide, and as a result CH3COO, the whole is twice Ca, and this is H2O. So this is making calcium ethanoate, so we have to make it balanced, so that's why it will be like this. Okay, let's take another example. CaCO3 is reacting with the HCl, and as a result it is going to make CaCl2 along with water and carbon dioxide. So this is one other category of the reactions in which metal carbonate is behaving like a base, and it is reacting with an acid to make metal salt, carbon dioxide gas, and water. Okay, so there is another category of the reaction in which ammonia is reacting with, for example, HCl, and here it is making ammonium chloride, and that is called as neutralization reaction. It is now reacting with the HNO3, and as a result of that it is making NH4NO3. There is another category. NH3 is reacting with carboxylic acid CH3COOH, and as a result of that it is making CH3COONH4. Okay, in the first category it is called as ammonium chloride, and in the second category it is ammonium nitrate, and in the third category it is called as ammonium ethanoate. Okay, ammonium ethanoate. Okay, now the point is this, that these are the few examples in which neutralization is happening. How neutralization is happening? Basically it is a reaction between an acid and alkali. I'm repeating my words again and again to fix the idea of neutralization in your mind. Okay. Now we are on the category number 2, and that category number 2 is the reaction of metal dash metal displacement. Metal dash metal displacement reaction. Okay. In this reaction, basically, a metal is displacing the other metal. Okay. How this reaction is happening? Basically, a metal salt, for example, a salt and a base are reacting, and as a result, salt and base are the products. Wow, what's happening here? Look at here, guys. So, for example, salt is of metal A and base is of metal B, but after the reaction, salt will be of metal A, whereas base will be of metal A. So both of the metals are switching each other's position, they are displacing each other, they are just exchanging each other's position. So we can say this thing, that this is called as metal dash metal displacement reaction. Let's have some examples. So we have an example of NaCl. It is now reacting with KOH, a base. As a result, KCl will be formed and NaOH will be formed. So here we can say this thing with the green color I'm taking. So this is now combining with this, the greens are together, you may say. Okay, so it is now making KCl, and the other partner is making NaOH. So they are just switching each other's position. Just take another example. It is now, for example, FeSO4, and we have another example of let's take a base CaO, or some other example can be taken as well. We can take magnesium hydroxide. Okay, hydroxide has a charge of -1, whereas magnesium has a charge of +2. So two plus charge of magnesium will be cancelled by two hydroxides collectively. So what will be the product in this case? It will be FeOH twice along with MgSO4. Both of the metals have switched each other's positions. Okay. Sorry, Bache. So that's why it is categorized as metal metal displacement reaction. I would like to give you 2 or 3 more examples related to this. So this is, for example, let's take FeCl2 plus we have another base, for example, NaOH, and as a result, what will be formed? NaCl. To balance the equation, we have to have 2 over here, and along with that, we have, it is NaCl, and this is FeOH twice. So that's why we have to write 2 over here. Okay, we can take another example. For example, we have a base from group number 2, and that is, for example, strontium oxide is reacting with a salt, and salt can be of zinc. Let's take a salt of zinc. It is zinc nitrate. Okay, and now both of them are switching each other's position. It will be zinc oxide along with strontium nitrate. So these all 4 examples are sufficient to inform you that which is the base. Whenever it is a metal oxide, metal hydroxide, or metal carbonate, better to focus on metal oxide and metal hydroxide. I am saying it again, better to focus on metal oxide or metal hydroxide being considering as a base. But whenever there is a reaction of a base with an acid, then metal carbonate will be considered as a base equally. Here I'm telling you that whenever metal oxide and metal hydroxide are reacting with a salt, they are exchanging each other's positions. Salt will become salt metal is now making base, whereas base metal is now making a salt. Okay, so they are switching each other's position. That's why this category is called as metal dash metal displacement reaction. Okay, right now we are on a new category, and that is called as a reaction between base and ammonium salt. Okay, this is a reaction of high industrial, you may say industrial applications are there, involvement of an industrial applications are there, and this is one of the big problem issue in the agricultural fields and lands, and how it is happening. We are going to discuss about that. Let's discuss, have a big discussion on the topic of number 3 reaction, that is a base plus ammonium salt. Okay, base plus ammonium salt. Okay. Sorry guys, what is ammonium salt? First of all, what is an ammonium salt? Ammonium salts are basically used as fertilizer. Okay, what is a fertilizer? It is a substance, it is a substance, you may say, which is used for promotion, which is used for promotion of plant growth, promotion of plant growth. Okay, now the point is this, that the fertilizer is added for the promotion of the plant growth. Where it is added? It is added to the soil. Okay, why base will be added to the soil? Now there are different reasons for that. I am now changing the board. There is a gas which is called as sulfur dioxide gas, and it is acidic in nature, and one should know this thing, that it is soluble in water as well. Okay, soluble in H2O. Now there are two sources for sulfur dioxide. What are those two sources? Number one source is volcanic eruption. Volcanic eruption is there, and there is another source, and what is that? And that is burning of poor quality coal, poor quality coal. Okay, might be in geography you have read that there is a coal which is called as lignite. It has sulfur content in it. It is considered as a poor quality coal. So when that coal will undergo burning process, burning in chemistry terminology is called combustion. Okay, combustion. Okay, so when that coal is undergoing combustion, what is happening? As a result, it is producing sulfur dioxide gas. Okay, so this sulfur dioxide gas is an acidic gas. It is soluble in water, and when there will be a rain, as a result of that sulfur dioxide being dissolved in rain. So now I'm saying that, so for example, rain is there. Okay, so now the gas rain is with sulfur dioxide, and rain will become acidic, acid rain. Okay, you may say it is called as acid rain. Yes, perfectly, it is acid rain. Okay, now I am changing the board to tell you another story about another gas. There is another gas which is called as nitrogen dioxide gas. It is a brown colored gas. Okay, there are two substances of brown color which you should keep in your mind. One of them is Br2 and the other is NO2. Both are brown color gases. Okay, NO2 is a gas, whereas Br2 is a gas when initially it is produced, but at room temperature it is liquid in the state. Okay, so NO2 is an acidic gas as well. I'm writing here, it is an acidic gas, and it is soluble in water as well. Soluble in water. And so now what are the two sources for nitrogen dioxide? Number one is car exhaust. Number one is car exhaust. And number two is thunderstorm, lightning activity, and thunderstorm plus lightning activity. Now what is happening actually? A lightning activity. Okay, so now the point number one is this, that in car exhaust, basically the temperature of silencer might be, many of you have already enjoyed this. Yes, it has happened with many of you now, that you people have experienced this thing. May Allah save all of us, that you have experienced this thing of having a high temperature of car exhaust or silencer of a bike or etc. It's up to a level that it can burn the skin immediately. It's a very high temperature, even when the car is parked after driving or something. But during a driving process, what's happening actually, the car exhaust is emitting the heat energy produced by the engine. So as a result, that heat is forcing nitrogen and oxygen of air to combine with each other to make NO2. Nitrogen has a triple covalent bond. I have taught you in the topic of you may say in the topic of covalent bonding. So over there, you people have read this thing, how to make nitrogen molecule. In nitrogen molecule, if there is a triple covalent bond, lots of heat energy is required to break that bond. That's why nitrogen and oxygen are combining due to high temperature of car exhaust, and finally they are making NO2 gas. Okay, this is one of the way for the production of NO2 gas. There is another way for the production of NO2 gas, is the lightning activity during thunderstorm. The lightning has a very high temperature in thousands. That high temperature is forcing nitrogen and oxygen to combine with each other to make NO2. So this NO2 is now a part of our atmosphere, a part of our environment. Now when there will be a rain, now there is a rain just like sulfur dioxide, we are raining here by the grace of Allah. So this is rain here, and now this rain becomes rain, and NO2 are here. So we can say this thing, that this is now an acid rain. Okay, this is now an acid rain. So there was another one source of acid rain was sulfur dioxide, and the other source of acid rain is NO2. Okay, now I'm marking a line here. So for example, this is what, this is a soil. Okay, so on that soil, for example, there is what is this happening, acid rain. Okay, so the problem is this, that due to this acid rain, the pH of the soil will be lesser than 7. It will become acidic. So as a result of this lower pH level, acidic pH level, it will reach up to a 5 or 5.5 even. Okay, so it is quite lesser pH. In this pH range, what will happen, all the plants will not be able to grow, all the plants will not be able to survive. So that's why we have to add an alkali, we have to add a base to the soil. Why? To neutralize the acidity of the soil. Okay, to neutralize the acidity of the soil. But unfortunately, what is happening, look at here, right now I'm saying that a base is added and a fertilizer will be added as well. Fertilizer will be added as well. As a result, what will be produced? Metal salt along with ammonia gas, and along with this water is produced as well. Okay, so from where this base is coming? Base is coming to neutralize the acid. Okay, I'm writing why base is added to the soil, to neutralize the acidity of soil. Now there is another problem. Why fertilizer is added? For the better plant growth. But what's the problem basically? The problem is this, that both of them react with each other, and as a result of that, ammonia gas is released as well. This ammonia is a gas, so I am making an arrow that gas is moving upward. Okay, so I can write a gas symbol here, G is there. Okay, so when ammonia will be leaving, as I'm writing here, as ammonia is leaving, as ammonia is what is leaving, so as a result, what will happen? Nitrogenous content of soil will decrease. Is that okay right now? So this is the problem with this reaction. Whenever we are adding a base to ammonium salts, which are used as a fertilizer, they are producing ammonia gas. And when ammonia gas will be produced, as a result, the content of nitrogen will be decreased in the soil. Okay. Let me change the page so that I may write down few examples. For example, base is, you may take base as sodium hydroxide, and you may take the fertilizer is ammonium chloride. As a result, NaCl along with NH3 and water will be produced. Okay. There is another reaction. For example, we are taking CaOH twice. This is a base. How we know? Because it has an OH group. And along with that, we are adding NH4 and O3. And now it's an ammonium compound. So it is acting as a fertilizer, and it will form calcium nitrate along with ammonia gas, and along with this water will be produced as well. So this is how the reaction is happening. So I am now telling you that as ammonia gas is being produced here and here, these are the two examples of this reaction which are telling you that as ammonia gas is forming, it is leaving the soil, and we can say finally that nitrogenous content of the soil is reduced, is getting decreased. I guess it is now very, very perfectly clear that how this reaction is happening between a base and ammonium salt. Examples are there at the last page. All the reactions between a base and acid base and metal salt base and ammonium salt are done basically. So please, I'm going to give you a review. So it is a base here, and it is reacting with an acid, and this is a base here, it is reacting with a metal salt, and there is a base here which is reacting with ammonium salts. Okay, so please, what is the product in this case? Depending upon, you may say salt and water. Okay, salt and water, and in this case it is salt and base are the products, but with different metals, obviously they are displacing each other's. So here it will be salt and you may say metal salt and ammonia gas and water. So here I have written the summary of the reactions of bases. Okay, so let's move to the next topic, and I will discuss the next topic of oxides with you and the contact process with you. Take care, guys. See you in the next class.